Today's lesson is on arithmetic and geometric sequences. We do pronounce that first word arithmetic because it is an adjective describing a type of sequence. If I was just referring to the type of math I was doing, I would call it arithmetic. So our first question is, what is the difference between the patterns? So if we look at the two patterns provided to us, we can see in the first one that these numbers are changing by a constant pattern. Each time to get to the next number, I am simply minusing 4. If I could not see that pattern, I could always work backwards and start with the end term and subtract the previous term to find what the pattern is. Now, if that doesn't work, then it's going to have to be a different type of pattern, or maybe not one at all. So if I wanted to check, I could say 0 minus 4, that gives me negative 4. 4 minus 8, that gives me negative 4, and 8 minus 12, that gives me negative 4. That showed me the pattern that this sequence is growing by. If I want to look at the other one, I see that I'm not adding or subtracting the same number every time, but there's something else going on here. To get to each successive number, I could simply multiply by 3. To work backwards, if I didn't see the pattern on this type of sequence, I could go to the last term and divide by the previous term. So I've got 27 divided by 9, 9 divided by 3, and 3 divided by 1, and they all tell me that the pattern was that I was multiplying by 3. So these are the two different types of sequences we'll be investigating. For the most part, if you were just finding the pattern or extending the pattern, you wouldn't really need to know all these formulas. But if they ask you for a number way down into the sequence, that's really what these formulas we're about to discuss are used for. So the first type of sequence, the sequence that grows by addition or subtraction, these are the ones that are known as arithmetic sequences. They model linear relationships, because if we know anything about a line, we know that it only grows by addition or subtraction. That rate of change or slope is only addition or subtraction. When we start getting into multiplication and division, that's a different type of function. So if I wanted to look at this pattern as just a linear function, I could consider that in the position 1, the first number is 12, position 2, the second number is 8, position 3, the third number is 4, and position 4, the fourth number is 0. Those are really ordered pairs. So I could plot these and it would make a line. I could write the equation for these ordered pairs based on what we know about the equation of a line, y equals mx plus b. I could find my change in y over change in x, and we've already discovered that's negative 4. To find my y-intercept, I can't say that it's 12 because that's what y is when x is 1. I would have to use the pattern and go backwards to find out what y is when x is 0. So if we were minusing 4 every time and we went backwards and added 4, we would know that when x is 0, y was 16, so that would be our y-intercept. Now that's what you already knew about linear relationships. Now that we're specifically talking about sequences, there's formulas that we use to describe these. So the first type of formula is a recursive formula. Now I'll be honest with you, these are kind of dreadful. They require you to know the first term and all the successive terms before the one you want. So if I wanted to know the 8th term and all I had was the recursive formula, I would have to go all the way back to the beginning and find out the first, second, third, fourth, fifth, sixth, and 7th term to find out that 8th term. So this is not commonly used, but you do need to be familiar with what it means if you see it. So for the sequence that we just had, 12, 8, 4, 0, if I wanted to use the recursive formula and write the recursive formula for that, I would first need to understand what all these variables represent. This a sub n just represents any position in the sequence. So these n's you see, if I wanted the 5th number in the sequence, that's where the 5 would go, where the n is. That's the position of the sequence. D represents the common difference. Arithmetic sequences have a common difference, which is the pattern, which is essentially just slope. So I would have to fill in the first number, because it builds upon the first number, and then build from there. So if I wanted to write the recursive formula just for any number, it would stay a sub n equals a sub n minus 1 plus the common difference. Well, on our example, it was minus 4 each time, so all that would be new in the actual formula would be a minus 4 at the end. If I wanted to use this formula, I always have to know what the first term is. They will always tell you a sub 1 equals something, because you cannot find out anything else without knowing the first term. In our particular sequence, a sub 1 is 12. That just means the first number in the sequence. Now, if I wanted to use this to find the next few terms, I would say a sub 1 is 12. We already know that one. So if I want to know a sub 2, I would have a sub 2 equals a sub 2 minus 1 minus 4. Well, 2 minus 1 is going to bring us back to a sub 1 minus 4. And a sub 1 we know is 12, that's the first term. So a sub 2, or the second number in the series, can be found by doing 12 minus 4. So a sub 2 equals 8. Well, that's true. The second number in the sequence is 8. Now we would have to know that one to find the third one in the sequence. So if I wanted to know a sub 3, it would come from a sub 3 minus 1 minus 4. So a sub 3 is equal to a sub 2 minus 4. A sub 3 is equal to, we now know a sub 2 was 8 minus 4. So a sub 3 should be 4. That's saying that the third number in the sequence should be 4. Okay, that's also true. But you see how this could be a cumbersome process. That is if it is recursive. Now, a much more simple formula is the explicit formula. Now, this allows me to figure out the number in the sequence way down the line. I don't have to come back and build upon the first one. Now, I do need to know what the first one is, but I don't have to, for example, if I was trying to find the 8th term, I don't have to know the 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th. I just at least need to know where I started and then the common difference. So in this formula, the explicit formula, again, a sub n represents any number in the sequence, like any position number. A sub 1 is going to always be the first number in the sequence. D is the common difference, which is the pattern, and again, n just represents the term number. So if I was going back to our original sequence here, 12, 8, 4, 0, and I was trying to write the explicit formula for this particular sequence, it would be a sub n equals a sub 1 is the first number, so we know that's 12, plus the common difference, which we know is negative 4. So really I should have wrote minus 4. You could write plus a negative 4, times n minus 1. Now I'm leaving n as n because I don't know what position number I'm looking for yet. That's the formula to find any number in the sequence. So previously I had to build upon the first to find the second, which allowed me to find the third. This time I could jump straight to the 4th term in the sequence. If I want to know a sub 4, or the 4th term in the sequence, I would find it by doing 12 minus 4 times 4 minus 1, because 4 is the position number I'm trying to find. I'm trying to find the 4th number in the sequence. So if I follow order of operations here, a sub 4 equals 12 minus, inside the parentheses, 4 minus 1 is going to give us a 3, and a negative, and the 4 times the 3 is going to give us 12, and so a sub 4 is equal to 12 minus 12, which is 0. Well, we got straight to the 4th term. This is why most people love the explicit formula way more than the recursive, because I could find the 300th number in this sequence without even knowing any of the terms in between. All I would have to know is the first one and the pattern. So it says write the recursive formula for the sequence. We technically already did that, so I'm going to fast forward here. So write the explicit formula to find any number in the sequence and then find the next 3 terms. Okay, so they're saying explicit formula. We're going to focus on that from now on. I told you that one was the easier one. That one is a sub n equals a sub 1 plus d times n minus 1. And I do believe this is on the formula sheet for the algebra test. We'll have to double check, but I do believe that some of the formulas are on there. So if I wanted to use the explicit formula for this new pattern, I first have to see that these are going down by 3, so minus 3 each time. And I know that my first term, a sub 1, is 9. So my explicit formula would be a sub n equals 9 minus 3 times n minus 1. So this is the formula that lets me find any term in the entire sequence. Well, they just asked for the next 3 terms. So if this is 1, 2, 3, 4, they're asking us to find a sub 5, a sub 6, and a sub 7. Since they're just the next 3 terms, I could really just continue the pattern. But now if they had asked us to find the 100th, 101st, 102nd numbers in this pattern, I would definitely need to plug it in. So we'll just practice with that just in case. To find, well, let's do it extending so that we could check. So if I extended this pattern, our next 3 numbers just by using the pattern should be negative 3, negative 6, and negative 9. So let's see if that's what we come up with. If I want to find a sub 5, that's going to be 9 minus 3 times 5 minus 1. So 9 minus 3 times 4. So that is 9 minus 12. So that is negative 3. That checks out. A sub 6 would be 9 minus 3 times 6 minus 1. So that's 9 minus 3 times 5. So that's 9 minus 15, which is negative 6. So that one checks out. And the last one would be the same. So it would become 9 minus 3 times 7 minus 1, which would be 9 minus 3 times 6, which comes out to be 9 minus 18, which is negative 9. So if it's just the next few numbers, you can just continue the pattern, but I did want to show you the formula in case it's way down the line. A couple more examples. Find the first term of the arithmetic sequence, if the first term of the arithmetic sequence is 1 and the common difference is 3, what is the 10th term of the sequence? So first we need to write the explicit formula. So a sub n equals a sub 1 plus d times n minus 1. So if I want to write the formula, they tell me what I need to know. They tell me that the first term is 1 and the common difference is 3. So this would be a sub n equals 1 plus 3 times n minus 1. This came from my first term. This came from my common difference. Now they want me to specifically find the 10th term, so they want us to find a sub 10 is equal to 1 plus 3 times 10 minus 1. Following the order of operations here, that would come from 1 plus 3 times 9, so 1 plus 27. So a sub 10, the 10th term in this sequence, is 28. Now, could I have just sat there and added 3 each time till I got to the 10th number? Yeah, but if it's like the 50th number, I don't have time to do that. That is what this is useful for. Okay, so given the explicit formula for the arithmetic sequence, find the term named in the problem. Okay, so they specifically want us to find the 27th term in this formula. So we're finding a sub 27. So that's going to be equal to negative 7.1 minus 2.1 times 27. So if I do my calculations by order of operations, I've got negative 7.1, and then negative 2.1 times 27 will give us negative 575.4, and then negative 71 minus negative 575.4 is going to give us negative 582.5. So a sub 27 is negative 582.5. That's just the 27th term in this sequence. Now, the explicit formula looked a little bit different. They really just distributed and cleaned some things up, and this looks a lot more like slope-intercept form, but it is still technically the formula. So, that's the end of the arithmetic sequences. Try the few problems located immediately afterwards, and then we'll talk about the next type.